Hi folks, this is Andy Kimmel. I'm a CS Principles teacher at Madison West High School, and I wanted to share some thoughts with all of you as you start this course about teaching CS Principles. Sorry about that. I've taught CS Principles several times now, 3 school years at Madison West High School, and then part-time as a college instructor at the University of Wisconsin-Madison. And I can tell you that every time I've taught CS Principles, the course is a little bit different. I've learned some things along the way, and I want to try to share some of those things with you. You're going to see a couple of slides that I talk about, and the framework for the thoughts that I'm sharing with you goes something like this. First, I'll start out by saying, rather than have this approach, I would suggest that you try this other approach. Let's see how that works. So for instance, you'll have some students in your class, and you might want to share with them reasons why you think it's a good idea to be in CS Principles and to take CS Principles. So rather than trying to turn your students into CS majors, I would really encourage you instead to remind your students about how computer science impacts lots of other fields. In fact, this is really a good chance for students to start talking about things they want to do after high school and careers they want to go into. So it's always helpful for you to show your students where computer science impacts those other fields. When you're organizing your topics for the course, rather than looking at the 7 big ideas of CS Principles and thinking, well, maybe I should just teach those 7 big ideas in order, I would like to encourage you to try to organize your teaching around themes and around innovations, and have the themes be the units in your course, and then try, if you can, to incorporate each big idea into each unit. My example of this would be talking about artificial intelligence. And I would have a unit in my course all about IBM's Watson and how it beat the best humans at the game of Jeopardy. We would talk about all the different big ideas in computer science that went into the making of Watson, like the creative idea that spawned the idea of making Watson, abstraction, algorithms, data, programming, impact, and internet. When you're talking about creating and creativity in your course, rather than only making artifacts with your students, and by the way, artifacts includes computer programs. Artifacts are really anything that a person makes using a computer. You should also give your students a chance, an opportunity, to think about new inventions and new innovations. That gives your students a chance to practice thinking abstractly, to think about the data that might be involved in their new app, think about the algorithm and what impact their new app might have, without having to require them to worry about how they would actually program it. In your teaching approach, rather than being a sage on the stage and worrying about what information am I teaching, how much information am I passing on to my students, and am I giving them absolutely correct, detailed information, consider instead being a guide on the side. That means you'll help your students construct their own knowledge. I have found this is especially true about topics like the internet or about algorithms. It is very hard in this course to explain to your students all the details of how the internet works. What you can do instead is share some key characteristics of the internet and then give your students chances to construct their own knowledge by doing some problem solving and some hands-on activities of some problems that were solved by the designers of the internet. And the same thing is true for algorithms. Rather than worrying about if you are teaching your students some complicated algorithms, even though they might be important, it might be helpful instead to give your students some problems to solve, like a sorting problem, and then have your students try to find their own solution and talk about their solution with their peers. When it comes time to discuss reading and writing in your class, rather than giving your students reading and writing assignments and just leaving it at that, you should consider instead how will you teach reading strategies to your students so that as they are reading, they are learning reading strategies. Or how will you teach writing strategies to your students so that they will learn good writing strategies as you are giving them writing assignments. You're probably thinking when you teach this course that there are a lot of expectations for you from your students and from your teachers and even from CS principals about what you need to do when you're teaching CS principles. And I would encourage you that instead of forcing your course to match CS principles perfectly, instead turn it around and figure out how can CS principles work for your situation. How will this course meet the needs of your students and their interests? Where are your students at? What do they need to progress through throughout this year? What works best in your school? And how will this course help fit into your overall computer science program? To wrap up, I want to encourage all of you to be innovative. Try whatever you think is going to work and learn from what works and what doesn't. That's really the best way to improve your teaching in general from year to year. And by all means, enjoy your experience as being a CS Principles teacher. This is meant to be a fun course. The students have fun, the teachers have fun, and we discover a lot of interesting things along the way. Good luck and enjoy the course.